This is project 1, video number 3, the video in which I write and run the code. I want to get myself into the right workspace. So I'm going to be working in spring 2017. So you store yours wherever you want, but project 1, choose that. Alright, then gotta fire up the editor. Want to write that first function. I think I decided I was going to return e_2, and I was going to, that's the return variable equal to the function name, which I just called, no, that was ex. e_x, and I'm calling this just ex. So the function name should be different than the return variable name. And this depends just on one variable, namely x. I'll type end in there so I don't forget it, and then I'm ready to start working on this function. I want to go back and see what I had in mind here. Under outline 1. So function e_x, so I gotta set k equal to what it's equal to. K equals, I think it's 8 point, I'm gonna have to look it up. Yeah, it's 8.99 times 10 to the 9, and the computer understands that e as times 10 to the, and then q equals 100 times 10 to the minus 6. I think I'll leave those off of there. Let's save it. Make sure I get those put in just right. The file name is supposed to be the same as the function name, so it should be ex. So ex, and the .m is going to be added automatically. Save, and sure enough, got ex.m over there on my workspace. And I want to try running that. So ex.1, it needs an x value, so I'll give it 1. 8.99 times 10 to the 9th, and 1 times 10 to the minus 4th, which is the same thing as 100 times 10 to the minus 6. This was Newton meters squared per coulomb squared. This is coulombs. Alright, so that worked. Let's put semicolons in there so it won't get printed out every time we go to use this thing. That's one of the requirements, that you don't have a bunch of junk printed out to the screen. Stuff that's not supposed to be printed to the screen. Alright, then getting back to what we wanted to do. Cook up that array of y values. I think I want to look at that as well. So y equals 0.0 minus 0.025 meters, colon, in steps of 0.002 meters. That would be a millimeter, 2 millimeters, colon, and let's make sure I got that right. Spacing of 2 millimeters, and then colon 0.025. Let's save that, see what that looks like. Go to the command window, run it. I'm just going to hit the up arrow, run it right away. So it's printing out, oh yeah, I told it not to print out the other thing. So starts at minus 0.025, then minus 0.023. That's looking good so far. and minus values, then minus 0.01 to 0.01, and I'll go forward to get the rest of them, and I get 26. The 26th one is 0.025, so I'm going to hit Q for quit and go back to the editor and say, yeah, that worked. I don't want that printed out every time. And then we have the R equal, so Y contains 26 values. Q just one, K just one value. And I think this is square root of x squared plus y dot squared, and the dot, I need the dot because I wanted to calculate R for every single element in Y. For each element, I'll get a different value of R. So if I leave out the dot, it thinks I'm trying to square a matrix, and I'm definitely not doing that. So I guess we can make sure that works too. So this is just the R values, and they're all positive values, and I'll go F for forward. And then I got 26 of them, so that's good. One could calculate some of those to check it, but I'm going to trust it. Put the semicolon afterwards. If things don't make sense, we can change that later. What do we got? And calculate the E. I'm going to try to look ahead a little bit. That's the wrong way to do that. E, and then the cosine theta, x over R, and E times cosine of theta. Alright, let's see what we got. E equals K times Q, and I do need the times symbol in there, which is an asterisk, divided by R to the power of 2. Now, R is an array, so when I do that to the power of 2, I actually need a dot power symbol. And I'm dividing by an array. I got to do that on an element by element basis. So a dot slash, this K times, I'm just multiplying by a number, so I don't really need one there. So let's not put one. And then cos theta equals x dot slash R. So the division on an element by element basis, because R is an array. And then E sub x, maybe I'll call it EX array. Not sure that that's exactly what I called it over here. Oh, I used EX, but I don't want to use the same name as the function. It could get me in trouble, so I'll call it EX array. Don't want to use exactly that. So I could call it something else, but I'm going to go with EX array. These names, you get to make them up yourself. Try to think of a better name than what I did and use that. EX array equals E dot star, so dot times cos theta. Alright, so again, this should be giving me 26 values stored in each one in an element of the array EX array, and EX itself is the sum of those values. There's a cool built-in function in Octave that just returns the sum of all the elements in an array. And that's exactly what we need. So, that should do it. So this should return the value of the electric field at 0.1 meters. I want to make sure I get the negative of that at minus 0.1 meters, so I'll do one little check on it. So the x component of the electric field at minus 0.1 meters should be the opposite of the electric field at 0.1 meters. It's like a rather huge electric field, which makes sense. Pretty big charge, actually, a lot of charge there. It should get smaller as this gets bigger. Let's make sure that's the case. Smaller in magnitude. And yeah, looks like I went another 0.05 meters. Another 5 centimeters. And we got less than half of what we had there. Again, with the positive, should get same value but opposite sign, except for the sign. Same magnitude, opposite sign. So it looks like it's working. Now I got to create another function. This one could conceivably be just a script, since it's not returning anything and it's not doesn't need any arguments. But I think in here I said you had to make a function. Yeah, write 2 Octave functions. So function, I'm going to call my return variable dummy because I'm not really using it, and I'm going to name the function graph EX, and it's got no arguments. Alright, so let's see what we had over when it was doing the pencil and paper part, what I had in mind. So exactly that, and then I said make a bunch of x values. So I'm using linspace, another built-in function, which gives you evenly spaced values from the starting point to the ending point, and this tells you how many values. So it did the same thing as what it did in the other function. Let's see if I can, how quickly I can get to that. I think I'm going to save this one. Save it as graph EX. Remember, I got to make it so it's got the same name as the function, and I did. Graph EX, and the .m gets added automatically, so I'll go ahead and save that one. Here's the list of the ones that I'm working on. So let's wanted to look at EX. Here was my point. So this does the same thing linspace does, but instead of specifying start point, end point, and the number of values, you specify start point, end point, and the spacing between the values. I guess in this case it was easier to use this because the problem statement gave us the spacing between the values. On this one, I would say it doesn't matter. So x equals linspace of it was 0 up to 0.15, I think. Yeah, 0.15, and I choose 151. See, 100 would be reasonable, for instance. All I need here, I'm making a graph, and when it does the graph, by default, it's going to connect the points together by straight line segments. Well, I want there to be so many points that it looks like a smooth curve, even though really it's going to be a bunch of straight line segments. So if it looks choppy, then I just bump up the number here. And had I done it the other way, all I would have to do is make the increments smaller, but I like the lint space for this one. And then we got to assign EX array is equal to EX of X. EX is the function that I just wrote, so it's going to calculate an array for me. Yeah, I think I've got an issue in here that we'll do when we'll deal with when we get to it. So I'll save it for the debugging stage. But EX array equals EX of X. Alrighty. So it's going to use the other function to calculate it and then store the results. Calculate EX at all these 151 locations and store the results in EX array. And then just write it a graph. So we use the EX array in the other function for something else, but it doesn't matter. Because we're in two separate functions. So each one defines it, uses it, and then gets rid of it, and then the other one uses it. But it does kind of indicate an issue here. Like this EX array has 26 values, and it's the contribution due to each charged particle. Over here in this function, I'm using the same word EX. I think I'll call it EX values. EX values equals EX of X. But this one's got 151 elements, and it's the total electric field at that point. Each one is the total electric field at X, as opposed to just the piece due to one particular charged particle. It's the total electric field due to all the charged particles. And then plot X comma EX values. And I think that should do it. So I think that the issue is that business of, in one case I got 26 values, in the other case I got 151 values. That this, when I call this, I'm getting an array, assigning, and within it, X itself is already an array, but then inside it there are other arrays. But we'll see. Let's see if it works. So I'm going to make sure I saved it, and then it's graph EX. So I can just type graph EX, open close parenthesis, no arguments. You can actually leave the parentheses off if you want. And then this is where we're dealing with the issues, like inside this guy, X is just a number, and so I'm treating it as a number here. And I think I still have problems if I fix that up. I'm passing it in a whole array of X values, but I guess I could try. Yeah, the thing is, there would be 151 values there, 26 values there. That's not going to work out. So I'll leave that as treating it as just a number. And then I'm going to use array fun. And this says evaluate it element by element. So editor, in here, I'm going to go array fun. And I think the way that works is I have to put an @ symbol here, It's actually the address of what that function is, and then I go comma. The x, as opposed to it being part of the parentheses. And if that doesn't seem to be working, then I'll look up array fun and include that in my documentation, wherever I get the help from. So save, and command window, graph ex, and it does seem to be creating a graph, and I think that's interesting. So it starts out at 0, shoots up, and then drops off rather gradually. I think it would have been more interesting if I had just actually plotted out to 0.05. Let's see if that's actually the case. I'm going to go 0.05. Still use 151 values. Control S, and then I gotta look at the, when that's already open, I gotta reopen it there. So it really has a sharp peak there. So let's try, I go 0.01, spread that out. Just see what it looks like, see if it makes sense to us. Oh, I want to edit that 0.01 and then save it, command window, enter, and take a look at the graph now. So it goes up and then it comes back down. I had it like really jagged up there on the one, so, and it is going to be smashed in here, but so it goes up and then it comes back down, and this makes sense. When you're right here, all the charge particles on the top are making a contribution to the electric field at the origin, which is downward, and the ones below the origin are creating an electric field that's directed upward, and they all cancel each other out. Then you move over a little bit and you get some x component that's not canceling out, so at first it gets greater, increases very rapidly as it turns out, and then it's as if you're giving all the charged particles a better angle for creating an electric field in the x direction. And then after a while, okay, the angle's getting better, but you're just getting farther and farther away from the particles, and so you get that die-off associated with 1 over r squared. Now, what it didn't like with the values that we're required to use, first off, I'll get that back in there. So I wanted to go 15 times as far as that, as it looked pretty jagged on the top. So I'm going to try 1501. So this is a lot of points. We're doing 1,000 points there. That's, over 1,000, 1,501 points. So let's see. It should peak very early, as it does, and still looking very sharp. I think it's always going to look sharp, but so that's probably didn't make any difference. Just make sure it went up almost as high there. Actually, I'm using a lot of points, but it doesn't really matter. So if I were to spread out the whole thing, so it peaks very rapidly, starts out at 0, peaks very rapidly, and then dies off. Alright, I think, which is what I would have expected it to do. I didn't, obviously didn't know how quickly it would be dying off there, or else I would have chosen a different value for your ending point on the graph, such as that when we had 0.01 was looking good. I think we're good. So you see what it looks like if we spread it out. So I'm going to call that the end of project 1 video number 3. It's the one where I just programmed it up but without doing any of the documentation.